Hello students, welcome to my class. Today we are going to discuss few questions related to aldehyde, ketones and carboxylic acid, and the pattern is NEET exam pattern. So friends, let's start with the question answer round. Now my first question is, look at what is given here. That is, wait for a moment, the CH3CHO, okay, C6H5CH2CHO can be distinguished chemically by which test? That is, as we all know, wait for a moment, that is, if I talk about CH3CHO, if I talk about C6H5, clear, CH2, then CHO. These two aldehyde is aliphatic aldehyde, clear? Yes sir. Aliphatic aldehyde. But if I compare this with C6H5CHO, this one is aromatic aldehyde, clear? Aromatic aldehyde. Now what the question say? CH3CHO, both are aliphatic aldehyde, then we people can say they will give Benedict test, Tollens reagent test and Felixson. This is very simple. This test are all for aliphatic aldehyde. Now what about the iodoform test? This is the prime concern. As we know, iodoform tests are given by those carbonyl compound which have CH3CO linkage, clear, or those alcohol which have CH3CHOH linkage like ethyl alcohol. Now in this case, what we observe, in case of CH3CHO, this is CH3CHO. In case of CH3CHO, there is CH3CO linkage. If there is CH3CO linkage, then the carbonyl compound gives positive iodoform test. Check it out. CH3CHO. CH3CHO. So acetaldehyde gives positive iodoform test. Yes sir, that gives positive iodoform test. But I am moving here. But if we compare this with, look at what I am telling, listen carefully. If we compare this with C6H5CH2CHO, there is no CH3CO linkage, so it will not perform positive iodoform test. So finally we can say these two can be distinguished by using what? By using positive iodoform test, and the reaction in this case, that is CHI3 plus SCOONA plus NAI, clear to you, plus H2O. This is the reaction. But in case of CH6H5CH2CHO, no reaction take place. There is no such reaction. I2 and then NaOH. No such reaction take place. Clear? Now I'm going to rub this part and we'll discuss the next question. So for this question, wait for a moment, we people can observe that is B is the correct option. For question number 1, B is the correct option. Now I'm going to rub this part and we'll discuss the next question. Now let's move to the question number 2. A strong base can abstract an alpha hydrogen. This is alpha hydrogen. Clear to you? What is given here? A strong base can abstract an alpha hydrogen from, as we know, just recall your memory, what is given here? A strong base can abstract an alpha hydrogen. That means to say they are talking about aldol condensation. And which compounds give aldol condensation? Do you remember? Yes sir, we do. That is aldehyde and ketones. So what will happen in this case? Which type of reaction they will give? If I take aldehyde, do you remember? That is, they forms aldol. That is CH3CHO. This is aldehyde. Again we put here COH and CH3. Clear to you? This can be written like this, or you may also write like this. That is H and this one is double bond O and this one is H. This is the 2 moles of aldehyde. When treated with base or acid, they combine and form. This is C, this is H. Put here OH, then C. Clear to you? This is known as aldol condensation. That is, a strong base can abstract alpha hydrogen. Clear to you? One more thing I have to mention here, that is the alpha hydrogen. Now here one noticeable thing, I am removing this and the best example is here. Look at what I am telling. If I put here CH3, C double bond O, that is CH3. Now you can easily understand by this example also. This one is alpha, this one is alpha carbon. So this hydrogen are alpha hydrogen and this hydrogen are alpha hydrogen. So what will happen in presence of acid or in presence of base? What will happen? They gives CH3, that is COH. Clear to you? Now wait for a moment. CH3, that is CH3. Clear? That is OH, then CO, then CH3. This is the component. Let me check once. That is C double bond O, CH3, then CH3. Clear to you? Now CH2, then H, then C double bond O, then CH3 in presence of base or acid. What will happen? This bond will break and this will come here and form CH3, COH. Then wait for a moment. Let me note down CH2, then C double bond O, CH3. Now you can easily understand by this example. This is a base. Presence of a strong base can abstract an alpha hydrogen from ketone. Alpha hydrogen. This hydrogen is alpha. There are many more reactions. This hydrogen is alpha hydrogen. So we people can say a strong base. What? That is, it forms, that is, we know that is carbonyl carbon is electron deficient species. So in this case, that is, if there is a presence of base, then ketones abstract an alpha hydrogen. So a strong base can abstract an alpha hydrogen from ketone. This is the best example. I have taken the aldehyde to best. By using this example you can easily understand. So for question number 2, we people can say that C is the correct option. Now let's move to the next segment. Next question. What will happen? Check it out. Now question number 3. the product formed in aldol condensation. As I told you in my previous example, the product formed in aldol condensation is 1 a beta hydroxyaldehyde or ketone. Is simple. So for question number 3, B is the correct option. Clear? I have given the example in my previous lecture. Again you can write, that is CS3 CO CS3. Clear to you? That is what will happen. That is it gives you CS3, then C, then CS3, put here OH, then CS2, then CO, then CS3. Alpha and beta hydroxyketone. If I talk about aldehyde, CS3, CHO, then what will happen in presence of a base? It gives you CS3, CHOH, okay, then CH2, then COH. Clear to you? Wait for a moment. Yes, this is the perfect reaction. Again I am going to explain. I hope in my last observation I have written the wrong one. That is in case of aldehyde, look at CH3CHO, double bond O, here is H, then HCH2, then C double bond OH. This will come here, that is it forms CH3CHOH, then here comes this one is H, that is CH2, this one is come. This shows that is alpha and beta hydroxyaldehyde and ketone. So for this question, B is the correct option. Now this is the correct explanation. Check it out. Now let's move to the next question. What is the next question? That is, let's read the question carefully. What is given here? That is, wait for a moment friend. A carbonyl compound react with hydrogen cyanide to form cyanohydrin, okay, which on hydrolysis forms a racemic mixture. Which on hydrolysis forms a racemic mixture of alpha hydroxy acid. The carbonyl compound is, what is the carbonyl compound? Either it is acetaldehyde, either it is ketone or something else. Look at what I am telling. That is what is given here. Check it out. A carbonyl compound react with hydrogen cyanide. This one is carbonyl compound is react with hydrogen cyanide given here. Then what will happen? Sir, it's very simple. It will form cyanohydrin, that is C, this one OH, and this one CN. Clear to you? OH and CN. Okay, now on hydrolysis, further hydrolysis, that is two situation. Complete hydrolysis gives alpha hydroxy acid, partial hydrolysis gives you amide. So the product here is C, that is OH, then C double OH, alpha hydroxy acid. Clear? Now read the second part. That is the carbonyl compound react with hydrogen cyanide on which on hydrolysis form a racemic mixture. If there is a racemic mixture, then definitely this carbon, that is this carbon contains the asymmetric group here. That is, if one is CS3, that is the second one is definitely H. If one is CS3 and other is CS3, then it will not form a racemic mixture because this one is not optically active. Now what will happen? If I take, that is asymmetric carbon CH3 and H, then what will happen? Check it out. CS3, now H. Clear? Now put here CS3, now H. Clear? Now put here CS3, then H. Now in this case, what will happen? That is, they are optically active. It will exist in two racemic form. The two racemic form is, wait for a moment, that is DLN form, optically active. Why optically active? This one is chiral center, chiral carbon. Clear friend? So they form, that is DLN form C. There is C. Here is OH. Clear to you? That's one. This one is CS3. Now this one is H, and this one is COOH. Wait for a moment. Check it out. C, then CS3. Okay. Now CH, one form OH, 2 carbon. Okay. Wait for a moment. So sorry. That is C. Clear to you? One cyanohydrin, that is the acetaldehyde. Put here COOH, that is put here OH, put here H, or put here CH3. That is the first form. And again, if you move this one is gives you L form. So we people can say that in this case, if there is a asymmetrical position, that is CS3 and H, that is the chiral center, and chiral center is optically active. And optically active, that is it forms D and L isomer. Clear to you what I'm telling? It gives you D and L form. Clear friend? So now we can easily observe that in case of this, that is the answer is nothing, that is acetaldehyde. For question number 4, A is the correct option. Now friend, wait for a moment. Let's move to the next segment, next question. What will happen? Check it out. Look at the next question. Which one of the following can be oxidized to the corresponding carbonyl compound? 2-hydroxypropane, that is CS3, CHOH, CS3. What is oxidation take place? As we know, oxidation gives you ketone, CS3, CO, CS3, and this is a carbonyl compound. So we people can say which one of the following can be oxidized to give can be oxidized to the corresponding carbonyl compound. This one is 2-hydroxypropane. So here this is not a correct name. The actual name is 1, 2, 3 propane 2-ol. What is the actual name? That is IUPAC, correct IUPAC name, propane 2-ol. Clear? So for question number 5, we can say A is the correct option. Clear? Now let's move to the next one. What will happen next? Check it out. Now that is question number 6. Aldol condensation, as we will not take place in, this is a simple question. As we know, aldol condensation was given by those carbonyl compound which contain at least one alpha carbon, at least one alpha hydrogen, that I'm telling. But if I talk about CS3, CHO, clear to you? Here look at this one is a alpha carbon, that is it contains alpha hydrogen. If I talk about CS3, CO, CS3, this one is alpha carbon, this one is alpha carbon, and the hydrogen attached to alpha carbon is known as alpha hydrogen, we people know. So aldehyde, acetaldehyde ketone can give, similar in the case CS3, CHO also. Here is CS3, CH2, CHO. Look at this one is alpha, this one is beta carbon. So it also contain, that is beta hydrogen. But if I talk about HCHO, look at this one. This does not contain alpha carbon. So it does not have alpha hydrogen. So if does not have any alpha hydrogen, then we people can say it will not show aldol condensation. So for this question, we people can say A is the correct option. For question number 6, A is the correct option. Clear? Now friend, I'm going to rub this part and we'll discuss the next one. Wait for a moment. Now let's move to the next segment. Question number 7. Iodoform test is not given by. What is the rule of iodoform test? As we know, if there is a CS3CO linkage or if there is a CS3CHOH linkage, then those compounds, those molecules can perform iodoform test. If I talk about 2-pentanone, CS3 CH2, that is C-pentanone, CS3CH2 CH2, then COCH3. This is 2-pentanone. Count the number of carbon, 1, 2, 3, 4, 5, that is 2-pentanone. 2-pentanone. Okay. Now look at, here is the linkage CS3CO. So it will give positive iodoform test. Now check out the next option. What is the next option? The next option is ethanol, CS3CH2OH. Clear to you? Now if I write like this, that is CH3, that is CHOH, that is it contains this linkage. So if there is a CH3CHOH linkage, then again it gives positive iodoform test. Now if I talk about ethanol, the third option, the ethanol is CH3CHO. Clear? Now check it out. It can be written like this, CH3COH. Clear to you? Look at, it also contains CH3CO linkage, so it will also give the positive iodoform test. Now moving here, check it out. That is, if I write like this, the second one is 3-pentanone, CH3CH, wait for a moment, CH2O, CH3, CH2CO, CH2, CH3. Clear to you? This one, 1, 2, 3, 4, 5, 3-pentanone. In this case, look at, not CH3CO linkage present. So we will say that it will not perform positive iodoform test. I am moving here, check it out. So for this question, now we can easily predict, now we can easily assume that is D is the correct option. It will not show positive iodoform test. Check it out, check out the explanation. CH3CO linkage, CH3CHOH linkage. So in this case, first one, second one and third one will show positive iodoform test, but the fourth one will not show positive iodoform test. Clear to you? Now I am going to rub this part and we'll discuss the next question. Wait for a moment. Now, question number 8. Acetone react with iodine to form iodoform. It is very simple. Acetone react with iodine to form iodoform in presence of universal reaction. Remember this? CH3COCH3 plus I2, yes sir, plus NaOH. It gives you CHI3, CH3, COONA plus NaI plus H2O. If there is any mistake in the balancing, you can do it. This is a simple thing. Let's again check. CHI3, CH3, COONA, 3NaI plus 3H2O. So what is the answer? We just need this one. That is NaOH. So we can say for this question, it's very simple. That is NaOH is the correct option. Now friend, I'm going to rub this part and we'll discuss the next question. Wait for a moment. Now the next question is question number 9. Aldehyde and ketone will not form crystalline derivatives. That is, it's very simple. Aldehyde is a theory type. Aldehyde and ketone will not form crystalline derivative with dihydrogen sodium phosphate, because in dihydrogen sodium phosphate, in this case there is no lone pair of electron present in phosphorus, so it will not act as a nucleophile. So we can say aldehyde and ketone will not form crystalline derivatives with dihydrogen sodium phosphate. So for question number 9, D is the correct option. Now I'm going to rub this part and we'll discuss the next one. Wait for a moment. The question number 10. Self-condensation of 2 moles of ethyl acetate. Self-condensation of 2 moles of ethyl acetate in presence of sodium ethoxide gives you, it's very simple, self-condensation ethyl acetate, that is CH3, CH2, COO, C2H5. Clear to you? 2 moles of ethyl acetate in presence of sodium ethoxide. What will happen in this case? Sir, tell me. It can be written like this. CH3, CH2, COO. Clear? Acetic ester, ethyl acetate. Now in that is ethyl acetate. So that is the thing. Sorry, not C2H5, CH3, COO, CH3. 2 moles of ethyl acetates. What? In presence of sodium ethoxide, it gives us, it's very simple, it gives you acetoacetic ester. Clear to you? What I'm telling you, it gives acetoacetic ester. I think now you can easily solve such questions. Now, let's move to the revision. For question number 1, CH3, CHO and C6H5, CH2, CHO can be distinguished by using iodoform test. For question number 1, B is the correct option. A strong base can abstract an alpha hydrogen from ketone, C option. For question number 3, that is beta hydroxy, aldehyde and ketone. For question number 3, B is the correct option. For question number 4, a carbonyl compound react with hydrogen cyanide to form cyanohydrine, which on hydrolysis forms a racemic mixture of alpha hydroxy acid. The carbonyl compound is, sir, is very simple. The carbonyl compound is, tell me, acetone. Alpha hydroxy acid. Wrong. Racemic mixture, acetaldehyde. Clear? A is the correct option. For question number 5, what? That is A is the 2-hydroxypropane. For question number 6, aldol condensation, that is A is the correct option. For question number 7, tell me what will iodoform test is not given by D, that is 3-pentanone. For question number 8, what will happen? NaOH. For B is the correct option. For question number 9, aldehyde and ketones will not form crystalline derivatives with dihydrogen sodium phosphate. D is the correct option. For question number 10, self-condensation of 2 moles of ethyl acetate in presence of sodium ethoxide, it gives you acetoacetic ester. Clear, friend, what I'm telling? Acetoacetic ester. So for this question, B is the correct answer. Clear? So I think now you can easily solve such kind of questions. So friend, time is calling. Time to say bye-bye. Thank you so much.